Okay, this video is on similar polygons, and in order for two polygons to be similar, two things have to be true. Their corresponding angles have to be congruent, and all their corresponding sides have to be proportional. So let's take a look at what that means with this example number one. Example number one, it says triangle ABC is similar to triangle DEF. This little squiggly line here means is similar to. And if I want to identify the corresponding angles and corresponding sides for these two similar triangles, there's a couple of ways that I can do that. One, I can just look at the picture for my angles. I can see that angle A and angle D are congruent because they have that single curved hash mark. Angle B and angle E are congruent, and angle C and angle F are congruent. So those are all of my corresponding angles. So I could just say the corresponding angles then are, see, angle A and angle D, that's one pair. Angle B and angle E, that's another pair. And angle C and angle F. Those are my pairs of corresponding angles. Now notice I can also identify those pairs of corresponding angles just by looking at my similarity statement. Angle A and angle D, notice those are the first angles listed in my similarity statement. It's the first angle in this triangle, and it's the first angle in this triangle. So they match up. I know those are corresponding angles. Same for angle B and angle E, those are the second angles. And angle C and angle F, those are the third angles. In a similarity statement, the corresponding angles always match up. So the first angle listed is always a corresponding angle with the first angle listed in the second triangle. Corresponding sides, usually the easiest way to identify the corresponding sides is once you have the two polygons in the same, having the same orientation, that is, they're kind of facing the same direction, then you just find the sides that kind of match up, the sides that are in the same position on the triangle. So for this particular polygon, this side of this triangle is kind of on the left side, and this is on the left side of this triangle, so those are corresponding sides. This side here and this side here, they're on the right side, so those are corresponding sides. And these are the two sides on the bottom, so those are corresponding sides. So I would say my corresponding sides then would be, if I name these using the labels for the sides, this would be side AB and DE are corresponding sides. BC and EF are corresponding sides. And AC and DF are corresponding sides. And if you notice, you can also see that in the similarity statement up here as well. Side AB, which is this side here, that's the first two letters in the similarity statement for this triangle. DE, that's the first two letters in the similarity statement for this triangle. AB and DE, those are corresponding sides. Now, it says write one proportion using pairs of corresponding sides. Well, that's one thing that we know about similar polygons is that corresponding sides are proportional. That means we can set up a proportion using pairs of corresponding sides. So let's see. How about I use, let's see, AB and DE, that's one pair of corresponding sides. So let's take 6 and 12. 6 and 12 are corresponding sides. That means this pair of corresponding sides is going to be proportional to another pair of corresponding sides. How about BC and EF? So that would be 4 and 8. And I can see that this is in fact a true proportion. 6 over 12 would be 1/2. 4 over 8 would be 1/2. So this is a true statement. These two pairs of corresponding sides are proportional. Now I could write several other proportions using these same two triangles. Let's see, I could say AC and DF, that's 3 over 6. That's proportional to, let's see, how about AB to DE, 6 over 12. So there are a whole bunch of different proportions that I could write using these two similar triangles because all of the pairs of corresponding sides are going to be proportional. Now let's take a look at something that is also important about similar polygons, which is this thing called a scale factor. A scale factor just means the ratios of the lengths of two corresponding sides of two similar polygons. So here's this same pair of similar triangles that we had before. This was triangle ABC, which is similar to triangle DEF. And we marked all of these corresponding sides in that previous picture. And this scale factor, all we have to do is set up a ratio between the lengths of any of these pairs of corresponding sides, and we're going to get this thing called a scale factor. Now notice the formula that we use to come up with the scale factor. You always want the ratio of an image side to a pre-image side. Let's say image side to a pre-image side. So, for example, if triangle ABC is our pre-image and triangle DEF is our image, in other words, this is like the triangle we start with and we dilate it to this new size over here. Well, if I want to calculate the scale factor, if triangle ABC is my pre-image, well, I'd put one of the sides of the pre-image, that's going to go on the bottom. So let's see, how about let me use side AC. So then 3 is going to be my pre-image side, and the corresponding image side is going to be 6, which means that my scale factor would be 6 over 3, or 2. Well, that's if triangle ABC is the pre-image. If triangle DEF is the pre-image, well, that means I've got different numbers on the top and the bottom. So if DEF is the pre-image, then let's just use the same pair of corresponding sides. If DEF is the pre-image, that means the DEF side is going to go on the bottom, so that would mean 6 goes on the bottom and 3 goes on the top, which means that my scale factor, if triangle DEF is my pre-image and ABC is my image, that would mean my scale factor would be 1/2. And you may notice that those scale factors are reciprocals of each other. And you may also notice that basically what the scale factor tells you is how much bigger is one polygon than the other one. So if ABC is my pre-image, I know that DEF is 2 times as large as my image. If DEF is my pre-image, then I know that ABC is 1/2 times as large as my pre-image. Now, example number 3. Example number 2 in your notes has 2 similar quadrilaterals. This one's actually pretty close to example number 1. Pause the video here and try this one on your own, and then we'll take a look at these answers. So I've got example number 2. Quadrilateral ABCD is similar to quadrilateral EFGH. I want to name the corresponding angles and corresponding sides just like I did before. All right, well, the angles shouldn't be too hard. Both of these they already have the same orientation, so I just need to match up my congruent angles. So angle A and angle E are corresponding angles. Angle B and angle F, angle C and angle G, and angle D and angle H. And I could also have done that by matching up my angles up here in my similarity statement. Corresponding sides, let's see, there's one pair of corresponding sides, there's a pair of corresponding sides, there's a pair of corresponding sides, and there's a pair of corresponding sides. So if I want to name these, let's see, let's start with AB. Side AB corresponds to side EF. Side BC corresponds to FG, side CD, and side GH, and let's see, side AD, and side EH. All right. Write one proportion using pairs of corresponding sides. All right, again, there are lots of different proportions that I could write. So let's see, how about, I'm going to use side CD and side GH. So 12 over 4. So 12 over 4, and let's see, how about BC and FG? So 12 over 4 equals 6 over 3. Whoops. Nine, 15, 12, 6, 5, 4. I've got an error here. These numbers are wrong. I got those numbers swapped up. That should be a 3, and that should be a 2. I believe that's right in your notes, but it was wrong. It was wrong on my board, and I knew it was wrong right away because my proportion wasn't working out. I was about to have 12 over 4 equals 6 over 3, and that wasn't working out. That was how I knew I had a mistake. So, okay, now let me back up here. Now my proportion, 12 over 4 equals 6 over 2. That should be my proportion. And this, I can see, is correct because 12 divided by 4 is 3, 6 divided by 2 is 3. Now I know I have a correct proportion. I can also check it by cross-multiplying. 2 times 12 is 24, 4 times 6 is 24. Now I know I have my correct proportion. And again, I could write several different proportions that would also be correct using these two similar quadrilaterals. Okay, my scale factors. Write the scale factor if ABCD is the pre-image. So if this is my pre-image and this is my image, so I can see I'd be going from a larger figure to a smaller figure, so I'm going to expect that my scale factor is going to be less than 1. So let's see, I need a ratio, and I need to put my pre-image side on the bottom. So let's see, how about if I use, this is my pre-image, let me use this pair of corresponding sides here. So 9 goes on the bottom, 3 goes on the top, which means that my scale factor would be 1/3. Now my scale factor if EFGH is my pre-image, now I could do this a couple of different ways. Since I already know the scale factor with ABCD as a pre-image is 1/3, I know that the scale factor if EFGH is a pre-image must be the reciprocal of that, which is 3. I could also set up the ratio and put the pre-image side on the bottom. So let's see, EFGH is my pre-image. How about let's use this pair of corresponding sides. I'll put this on the bottom, which is 5, and I'll put its corresponding side on the top, that's 15, and sure enough that turns out to be 3. All right, example number 3. I've got two triangles. I'm told these two triangles are similar. And I know what the corresponding sides and angles are based on the similarity statement. And it says find the scale factor if triangle JKL is the pre-image. Now this one looks a little bit different because I noticed that my two triangles, they don't have the same orientation. They're not really lined up. So the first thing I'm going to do is I'm going to take this triangle and I'm going to turn it. I'm going to rotate it so that it's going to be facing the same direction as this triangle. That'll make it easier for me to match up the corresponding angles and sides. So let me take this triangle. Let's see if I rotate it. If I rotate it 180 degrees this direction, then let's see. Okay, my right angle is R, so that's angle R. And let's see, R comes down here, T is going to be over here, and S is this one up here. That's where my 50-degree angle is. And let's see, side ST, my hypotenuse, that's my 15, my length of 15. Okay, so now I have my two triangles, they're facing the same direction. Now it's going to be easier for me to match up my corresponding sides and angles. So I can see this is a pair of corresponding sides here. This is a pair of corresponding sides here, although I don't have anything there. And this is a pair of corresponding sides here. All right, now it says find the scale factor if triangle JKL is the pre-image. Well, I know how to find the scale factor. I just plug in a length of a side of my image over a length of the side of my pre-image. Except now, I've only got one choice for finding my scale factor because I only have one pair of corresponding sides that both have numbers in them. That's this side here and this side here. I can't use this side and this side because I don't know the length of side RT. I can't use this side and this side because I don't know the length of side RS. So I want to put my pre-image number here in the denominator. I'm going to use this pair of corresponding sides. My pre-image number is 20. My image number is 15. And if I reduce that, then that becomes, let's see, 5 goes into 15 3 times, 5 goes into 20 4 times. So my scale factor, if JKL is my pre-image, my scale factor is 3/4, which tells me this triangle is 3/4 as large as this triangle. Now, part B says find the value of any missing sides and angles. So there's a couple of different ways I could do this. I could set up a proportion. I could maybe call this X and call this Y and set up a proportion to find X and to find Y. So let's try that method. Let's see. If I want to find, let's start with X. I know I can set up a proportion using my corresponding sides, so I could say 20 over 15 equals 12 over X. And then I can cross multiply and solve this proportion. So let's see, 20 times X equals 15 times 12. Let's see, 15 times 12 is 30, 15, 180. And if I divide both sides by 20, divide both sides by 20, then I get X equals 9. Or, since I know what my scale factor is, I already found my scale factor is 3/4, I could just take this side, multiply it times my scale factor, and find the length of this side. So let's see, 12 times 3/4, that's 12 over 1 times 3/4. Let's see, that's going to be 36 over 4, which is 9. So I could find those values either way. So there's one side. I want the other side. I think I'm going to use the scale factor method. That seems a little bit easier to me. So I take this, multiply it times my scale factor. That's going to give me 16 times, scale factor is 3/4. So let's see, that's going to give me 16 times 3, 18, it's going to be 48 over 4, and 48 over 4 is 12. So I know the length of this side is 12, and the length of this side is 9. Now you've got another example in there, example number 4. I want you to try that one on your own, and we'll take a look at this one in class.